In this video, we're going to take a look at how to factor hard or difficult or challenging or complex trinomials, whatever you want to call it. But they're different from simple trinomials because of the presence of a value here where we would expect the a value to be the stepping pattern in the quadratic, and it's not 1. And if I take a look at this value of 2, my first step before I factor any trinomial is to take a look and see if I can common factor out a value. And I can clearly see that there's no way for me to get rid of this a value through common factoring. There's nothing common that can go in there. So I'm stuck with the way it is, and I need a process that will allow me to turn this into two terms or two bracketed terms that are multiplied together, and that will make it very easy for me to then, for example, solve for the zeros. So how do we get started? Well, first thing we're going to do is we're going to take this a value in front and we're going to multiply it by the value at the end. So we've got 2 and negative 21, and that's going to give me negative 42. Okay, let's not focus on the negative just yet, but rather we're going to focus on the 42. And then what I want to do is I want to write the factors of 42. Well, we know that 1 times 42 gives you 42, 2 times 21. How about 3 times 14? And 4, no, 5, no, 6, and 7, and then those are all the factors. Okay, now let's take a look at that negative. The negative value on the 42 means that one of these values is going to be positive and one is going to be negative, because the only way to multiply two values together and get a negative answer is if the signs were opposite. One was positive, one was negative. So which term do I put the positive on and which do I put the negative on? Well, let's draw our attention over here back to the trinomial and look at this middle term of negative 1x. So this is telling me the result of the addition of these two factors. So I need to choose two factors. Remember, one will be positive, one will be negative, that when I combine them, I'm going to have an answer of -1 or -1. And I think you can clearly see that the two factors that seem to be standing out are 6 and 7 here. And if I was to place the positive with the 6 and the negative with the 7, when I add those together, I'm going to get -1. So these two are the factors that I'm going to use to complete this question. Okay, so now that I've chosen the factors that are going to work, what's my next step? Well, the next step is this. I'm going to take that middle term, so I'll write the 2x squared, but this negative 1x, I'm going to replace that and put the positive 6 and -7 in its place. Now, which do I write first and which do I write second? Does it matter? Well, if I just do a little bit of forethought here, if I pair the 6 up with the 2, they're both even numbers, and it would be probably pretty likely that I'd be able to, I know I would be able to, pull out a common factor from those. Similarly, the 7, if I write that second, it's going to be sitting beside the 21, and those look like they would be a good pair to look for some common factoring. So I'm going to do that. I'm going to put plus 6x and then immediately subtract 7x, and then I will finish up with what was originally there, the -21. And you'll notice that I haven't broken any rules. I could very easily move backwards and get back to my original question by just combining these two like terms. So I could take 6x and subtract 7x, get -1x, and I have simplified by collecting like terms, and I'm back where I started. So I know that I'm on the right track. So what do we do now? Well, here's what we're going to do. We're going to do a little bit of grouping. I'm going to focus my attention just on the first two terms, and I'm going to look for something that is common in both those terms. So I'm going to do some common factoring here. Well, I look at first the coefficients in front. I've got 2 and 6, and I know that 2 is a common factor with that. Then I'm going to look at the variable term. So I've got x squared and x, and I can actually pull out a common x from that. So remember, factoring puts brackets back in, and it creates multiplication. What's left inside the brackets? Well, when I take 2x squared and I factor out 2x, all that remains inside is x. And I can check my answer. 2x times x is 2x squared. Good. And then all that's going to remain in the second term is 3. And I can check my answer. 2x times 3 is 6x. Good. Let's carry on to the next one. Let's look at these last two terms. Okay, well, if I look at what they have in common, they're both negative, and it looks like 7 would be a good common factor that would go into both of these terms. So why, am I kind of looking at the fact that they're both negative? Well, I'm going to look ahead and realize that if I could get an x plus 3 in some brackets right here, then that would be perfect, because that is what I'm shooting for. So if I factor out a negative 7 out of that first term, well, then all I have left inside is x. And check my answer, negative 7 times x is negative 7x. If I also factor out the negative 21 and say I'm going to take negative 21, factor negative 7 out, I'm left with positive 3. Checking my answer, negative 7 times positive 3 is negative 21. And because I have created two brackets that have exactly the same thing inside, namely x plus 3, I can now common factor one more time. If I look at this term here and consider this entire multiplication term as one term, and this entire term as one term, I can now common factor out the x plus 3 out of both. So x plus 3 comes out. What's left in the first is 2x. And what's left when I take x plus 3 and factor it out of the second is the minus 7. Okay, so there we go. We have taken this hard, difficult, challenging, whatever you want to call it, trinomial, and we have factored it into x plus 3, 2x minus 7. Now, if I want to take one more step and do something that I'll typically do at the end, is if I set this to 0, I could ask, when is x plus 3 equal to 0? And that is true when x is negative 3. I could ask here, when is 2x minus 7 equal to 0? That's true when 2x equals 7. Move the 7 to the other side. And that is also true when x equals 7 halves. Divide both sides by 2. These two values are the zeros of this quadratic. And I know a couple things about the quadratic. I know that it has a stepping pattern of 2, so it opens up, it's positive. And I also know, because this is standard form, this negative 21, that's where it crosses the y-axis. So I have a lot of information that I've been able to pull out of this quadratic just by factoring. But that's how we factor a hard trinomial. Well, let's do one more example. Let's say we were asked to factor this trinomial here. Well, a couple of things sort of come to mind right away. If I take a look at this trinomial, I notice that there is an a value out in front. I also notice it's negative, so this is going to open down. It's not a simple trinomial because of that a value. And you might think that, okay, well, let's go ahead and immediately start to multiply these two, the negative 9 times negative 30, and look for factors. But remember, our first step is to always look for a common factor. And if I look at all these values, well, 9 does not go into 33 or 30, but 3 does go into all of these coefficients, negative 9, negative 33, and negative 30. So my first step is going to be to factor out, and I'm going to take the negative as well, negative 3. Okay, so when I do that, when I factor out negative 3, what's left inside? Well, I'm left with positive 3 x squared. Negative 3, that gives me a positive 11x. And negative 30 divided by negative 3 is positive 10. So now I have smaller values inside the brackets here, and it's going to make my factoring task a little easier. Okay, so I'm just going to keep that negative 3 there, and then we're going to address this complex or hard or difficult trinomial. So remember, the first step is we take this 3 and multiply it by the end, and in this case we're going to get that is positive 30. Okay, well, what are the factors of 30? I know it's 1 and 30. 2 times 15, 3 times 10, 4 no, but 5 times 6 is also 1. And those are the factors. All right, now let's look at this positive 30. Okay, so it's positive, and that means that two things could have happened. Either we had a positive 1 and a positive 30, that when I multiply them I get positive 30, or negative 1 and negative 30. Both of them are negative. So the positive 30, if the value when we do our first multiplication here is positive, both of these values have the same sign. So let's just take a peek at the middle term now, and it's positive 11. All right, so I know I'm working with positive values over here. Both of them are going to be positive. All right, so pretty easy. If we decided right away and I said, all right, both of them are going to be positive, then I can put all these positive signs in here, and then I just have to look for two factors that when I add them together give me 11. And I think you can clearly see that the last set here, positive 5 and positive 6, are going to give me positive 11. All right, so we're going to break this, decompose if you like, or use grouping. We're going to take that 11x and I'm going to split it up into 5x and 6x. And I guess the first question is, where should we put the 5x and where should we put the 6x? Which should we write first? Well, I'm going to try and be a little smart about this. I'm going to look at the 3x squared and say, what should I pair up with that? What might be a good value to place with it where common factoring could occur? And the 6 would seem to be more likely than the 5. If I place the 5 second, notice it's going to be paired up with a 10, and that looks like a good opportunity for common factoring. Okay, so I'm going to do that. I'm going to take 3x squared. Actually, let's make that black. So 3, there we go, x squared, and the positive 10, they stay exactly the same. I take the 11x though and I break it up into two pieces. I'm going to say that's the same as positive 6x, add another 5x. And you'll notice that if I work backwards, if I try and go back to this step here, it works fine. I just add these like terms and I'm back where I started. So I'm checking my answer as I go along and everything's working really well. All right, well, the next step is going to be, well, this negative 3 out in the front doesn't change, so I'll keep my brackets there. But I'm going to take a look at these two terms right here. And I'm going to ask myself, what common factors out of there nicely? Well, look at the coefficients. Got a 3 and a 6. 3 is going to factor out. Look at the variables. X squared, x. X is going to factor out. What's left? Well, we're going to have an x, because 3x times x is 3x squared, and we're going to have a 2. 3x times 2 is 6x. I'm checking as I go to make sure that things are working out. Focus on these last two terms now. What do they have in common? Well, when I look at them, it looks like there's a 5 and a 10. I think positive 5 would certainly come out of both. And then when I look at the variables, this has an x, this doesn't have an x, so I can't factor out any variables. What's left in the brackets? Well, 5 times x gives me 5x, and 5 times positive 2 gives me positive 10. If everything has gone correctly, you should have the exact same thing in these two brackets. Therefore, when I look at these two terms, when I say, oh, there's a term joined with addition with another term, I can then common factor out that x plus 2 out of both. So we get minus 3 bracket x plus 2 and bracket what's left. Well, we got a 3x in the first term, and what's left was the plus 5. Okay, this extra set of brackets here around the whole thing, I can just remove those. They were just holding things in place while we got going. And there is the entire difficult, challenging, hard trinomial factored. I know it's a quadratic. I know it opens down because of the negative. I know it has a stepping pattern of 3. I know that it crosses the y-axis, if I look back up here at the start, at negative 30. And if I set this to 0 and I ask the question, when is x plus 2 equal to 0? Well, that's when x equals negative 2. When is 3x plus 5 equal to 0? Well, that's when 3x is negative 5, or x is negative 5 over 3. So those are the two roots. That is where this parabola crosses the x-axis. All right, so a couple things with factoring hard trinomials. First thing you always want to do, look for a common factor. See if you can pull out a common factor and make your life easier. And just follow the steps one at a time, and you won't have any problem factoring trinomials that look difficult, but they really aren't.